In the last module, we estimated a value and learned about the method of testing hypothesis only for one set. So for example, we look at the case where we're testing the hypothesis about proportion, and we set the proportion to be equal to some number. And the alternative hypothesis was either p is less than some number, p is greater than some number, or p is not equal to a number. Similarly, for the mean, we set the mu to be some number, and the alternative hypothesis was either mu is less than some number, greater than some number, or not equal to a number. In Module A, what we do is we extend the methods to two sets of data. So what we're going to do is compare two means and two proportions. As you see, the calculations are pretty cumbersome. The formulas are long, but we'll use Excel to do the calculations. And we learn about this topic because it is important in statistics, and a lot of times in the real world applications, they involve claims about two samples. So this is an important topic to learn. The good news is the general procedure for hypothesis testing, it's the same as last time. So we set up the null hypothesis and alternative hypothesis, look at the alpha. Typically it's 0.01 and 0.05, and then determine whether it's a one-tail or two-tail test. Determine the test and calculate the appropriate test statistic. So it's either going to be z or t. And using the p-value method, we'll use the rules where if the p-value is less than alpha, reject the null hypothesis. Otherwise, do not reject the null hypothesis. So let's look at the example about the claim about two proportions. So here are the numbers you need. Population proportion 1, sample size 1, number of successes, x, and p1 hat, the formula for that is x1 divided by n1. That's a sample proportion 1. And q hat 1 is similar to last time. It's going to be 1 minus p1 hat. And then since there are two sets of data, you do the same thing for p2, n2, x2, p2 hat, and q2 hat. And if you're calculating proportion, testing about the proportions, you will have to calculate what we call the p-bar. And the formula for that is x1 plus x2 whole thing divided by n1 plus n2. And then as you can guess, q bar is 1 minus p bar. We'll use that z as a test statistic, and formula for that is here. It's kind of long, but we'll use Excel to figure that out. And we're going to be using the p-value method. Alpha is typically 0.05, and we'll use Excel to do the calculations. Oh, and then the confidence interval is written as this way. And the formula for the margin of error is E is equal to z of alpha divided by 2 multiplied by this whole thing in the square root. So let's look at the first example. So let's say we want to know if airbags do save lives. So we collected the data, and we look at the number of people who die with the airbag. That was 41, and without the airbag there's 52. And out of 11,541 for the airbag yes, and airbag no was 9,853 people. So we're going to assume that P1 to be P1 equal to P2, so airbags don't make any differences. And we'll say, okay, P1 corresponds to the proportion with the airbag. So we're going to assume that proportion is going to be less than P2 where it's without the airbag. So let's go to the spreadsheet to figure out the answer to this question. So here's a rehash of the problem. And I retyped the data here. So x1 in this case is 41, 52 is x2, n1 is 11,541, and then n2 is 9,853. So I want to calculate the p hat. And the formula for that is x1 divided by n1 using these two numbers. And q hat is 1 minus p hat, so 1 minus the one number above. And I do the same thing for q2 hat, I mean p2 hat, these two numbers. And then calculate the q2 hat subtracting from 1. So the p bar is, the formula is x1 plus x2 divided by n1 plus n2. So using that formula, these are the numbers I use. Just a little warning, don't forget to use the parentheses here. A lot of people forget that and get the wrong number. And q bar is going to be 1 minus the number above. Okay. Here's the crucial part. So the formula for z is this whole thing. P1 bar minus P2 parentheses minus P1 minus P2 over square root of this whole thing. So in this cell, that calculation has been done for you. Guys, if you follow the cells, they correspond to the right numbers. So one thing about this formula, we assume P1 minus P2 to be 0. So that's why there's a 0 here. So it's always going to be 0 for your in this class. So once you find the z, the rest is the same. Plug it into the norm.s this function, and we get the p-value of 0.08, say. So is that bigger than or smaller than 0.05? So in this case, it's less. So that means we can reject the null hypothesis, meaning that airbags do seem to have an effect in saving lives. Okay. So what's the margin of error? The z alpha divided by 2 will be given to you. It's typically 1.96 as seen here. And here's, I punch in the formula for the margin of error, this whole thing. And the confidence interval will be from this formula, B16 divided by B19, which is these two numbers, minus the minus this proportion here, minus margin of error, and same thing up here, except it's a plus. Okay. So since the p-value is less than 0.05, we reject the null hypothesis that the airbag does not make a difference, i.e., airbags does seem to save lives. Okay, that's how you do proportion problem, two proportion problem. So let's go back to the lecture notes. And we're going to test a claim about two means from large independent samples with unknown sigma 1 and sigma 2. So we don't know the sigmas. And we're going to assume they're not the same. If that's the case, we're going to use the t distribution for the test. So then the test statistic will be t. To do that, these are the things you need: the population mean, the sample mean or sample size, the sample mean, the population standard deviation, and the sample standard deviation. And you do the same thing for the second set: mu2, n2, x bar 2, sigma 2, s2. And then here's the formula for the test statistic, which is t. And rest is the same. We use a p-value, and then critical value, we use Excel to figure those out. Here's a confidence interval formula. And the margin of error is this thing right here. So we'll be using these formulas and then numbers from here in Excel. So let's look at the claim about the one gender talks more than the other. So let's go to the spreadsheet to figure out which sex, so the male or female, talks more than the other one. All right, it's an eternal battle of sexes. Do women talk more than men do? There was an actual study that was done to test this hypothesis, so the data is given below. And we're going to test the claim that the one sex talks more than the other one. So let's set the alpha to be 0.05, and we're going to use 1 to designate male, number 2 to designate the female. So that now hypothesis will be that we're both equally talkative. So mu1 is equal to mu2. And the alternative is going to be men talk less, so mu1 less than mu2. How the test study was done is that somebody counted the number of words a man talks in one day and counted the number of words a female talks in one day. So that's why we use in the averages. So we took the average of many different men and many different women. So the data collected shows there were 186 men were surveyed and 210 women were surveyed. And then for the average words spoken by sample men in the day was 15,669, and the average words spoken by sample women in the day was 16,171. So here's the data for the words. So here's the data. So we took a sample mean of all these numbers here for the male, and then all these numbers for female. Okay. Using the data, we can calculate the sample standard deviation for men and the sample standard deviation for women, and these are the two numbers. So here's a summary of the data. There are 186 men, 210 women. Using the average function, I figure out how many words average male speaks. Same thing for female here. And using the standard deviation.s function, calculate the sample standard deviation here for men. Same thing for women here. The degree of freedom is going to be lesser of the N1 and N2. Remember that the t distribution requires degrees of freedom. So degrees of freedom for t distribution is, in this case, will be smaller of these two numbers. So that's why it's 186 here. And here's a formula to calculate the t-test statistic. Okay. So here's the formula for all that stuff. And again, we're using the t-test because the population standard deviation, which is the sigma, was not given to us, and we manually calculate the sample standard deviation. So we're using the t-distribution test. Okay. So calculate the p-value. Here's the formula for that. And the p-value we get is 0.25. Okay. So what does that mean, 0.25? Well, since the p-value is greater than 0.05, we cannot reject the null hypothesis. So that means it appears that the men and women were equally talkative. So it's been proven that the women don't necessarily talk more than men. And the margin of error for calculations here, so it's t times this thing in the square root, and the confidence interval using this formula, it's going to be 790 and then 1883. Another way to use confidence interval is that if you look at it, this is a positive number, this is a negative number, so there's a 0 in between these two numbers. So that means the number of difference is 0. So then we are confident that there's no significant difference between two means. So the two means of spoken words of two sexes. Okay, so that's how you do problem like comparing two means with unknown sigma 1 and then sigma 2. And if you have to make inferences from dependent samples, here's how you do it. Okay. So that concludes the Module 8 sample problems.